Good day and welcome to this video in which we are going to look at checking and correcting text data using Excel. And this is useful if you are using this technique with the JunoViewer ICC template or with the Juno-Cassandra check and add columns template, or also if you are wanting to just check the input data that comes into your deterioration model setup file or DMS in JunoViewer. Now this is a follow-up video from a previous one that we've done entitled Checking and Correcting Numerical Data Using Excel. This data is considerably shorter and simpler than the one dealing with numerical data, and I want to really encourage you to please go back and watch this video on checking and correcting numerical data before you watch further this video, because the video dealing with numerical data will set the foundation and explain some of the principles behind the ICC template and the Juno-Cassandra check and add template. So it is important for you to understand that. And also we are going to build further on an example that we started in the previous video. So please go and watch that video and then continue with watching this one. So let's look at the approach that we are following to check and validate our text data. So we start again here with the raw data value. And this raw data value is then first of all going to be checked to see whether it represents missing or unknown cases. Right? If it does, then we set the value that is going to go into the output as either no data or default, whatever values we want to put in there, into those square brackets we can put in there. If it does not represent one of the missing or unknown listed values, then we are going to check whether it's a valid value. Now, in some cases, you will want to accept any value. For example, a comment that a user makes on a road inspection or an asset inspection. Normally, they would enter anything. But if you are dealing with something like a material type or a classification for an asset or something like that, then normally there would be a list of accepted values. And your model or whatever downstream algorithm is going to work with your data will typically only be able to handle those values. And so that's what we want to achieve with this process, is to correct any cases that fall outside of the accepted values. So here we're going to check, is it a valid value? If it is not, then we are going to either set the value to error or unknown. Whatever we want, we can put into those square brackets. And that will go to the downstream process, and the downstream process should then know how to handle those values. If it is a valid value, then it's simple. We are just going to take that final value and it's going to go into the next process. So it's a little bit simpler than the numerical case that we handled before. So let's go over to Excel and build forward from the example that we had further and look at the details of our formula. Right. So here I am in my Excel template, and you can see I'm working again in the Juno-Cassandra template for adding values and checking values in the pre-processing stage. If you're working in the JunoViewer ICC template, like I said in the previous video, these column names and the positioning of the columns will look different. But the principles that we're applying with our formula here will be the same. So all you need to do is just make an adjustment to the location of the cells, but the formulas in this area is going to be the same. Now you can see here in these columns over here, I've got the example that I've done in the previous video dealing with numerical data. And I'm clearly delineating using colors which columns, these are my columns over here, which columns are numerical. These are the yellow colors. And then these are the new columns that I've added, and they are going to be, I'm expecting text values in there. So for this example, I'm dealing, for example, with a building asset, and I'm looking at parts or equipment in the building, and I've got a zone for the building, for example, forest and lake, weather rating for the building, the type of part, and let's say something like a rust rating, and these are all text values. I've also got install date here. We're not going to deal with that in this video, but so it's important to use this color scheme, because you may be tempted to take some of these formulas that apply to the numerical case columns and just drag it down, and if it's different for the text columns, then you are going to run into problems. Okay, so we are going to start off by again taking the lowercase of the trimmed value that is in this raw data cell over here, right? And so we can just use that. And I'm just going to copy this and paste it as a formula. And I've got those values over there. And then what I've put in down here are the valid names for zones, valid names for weather rating, part type, and rust rating. So these lists don't have to be the same length. I've just kept it simple. You can see the zones, there's quite a bit more, and I've put all of them in there. So let's say, for example, my downstream process will only accept and be able to handle these values. So that's what I need to check for. Now, in the first instance, I want to check again whether or not the value in this field is matching any of my no data values or not. Now, what I've done is to put my no data values, which I've discussed in the previous video, on a sheet here called lookups. So there's my no data values, right? And I've also named this range no data values, so that if I go back to this sheet and I look in there, you'll see I no longer use a range of cells. I use a named range in there. And that means I can easily just copy and paste this formula. And remember from the previous video, if this says NA, it means this value is not in the list of known values, so it's not no data. So I can again make use of this formula and just paste it as a formula in here, right? And so you can see, because this zone, forest and lake, is inside of this list of valid values in here. See, there is forest and lake. Now note that this match does not does a case insensitive lookup. This match formula that I've got here, it does a case insensitive lookup. So even though this forest and lake is not the same case definition as this, it will still pick it up in here. So if I go and I change this now to no data, for example, you'll see that my no data will become true here. So that means this is not a valid value, it's a no data value. The next one is whether or not it's valid. Now, in the case of numeric data, I looked at whether it's a number or not. Now, all of these formulas I've just basically could have copied down. So they are the same as for the numeric case, but here it's starting to be different, because now what I want to do is to see whether or not this value, this raw data value, is in the list of acceptable values. So here I'm just going to use, again, I'll do it in two stages. So first I'm just going to put first part of the formula, and then I'll make it a little bit complex later on. So I'm just going to say match, look for the match of this value in here, in this list over here, right? And I want to have an exact match. Right. Now it says not applicable because it's a no data value, right? So if it's not applicable, then that means this is not valid. So I'm going to now modify this formula by saying if is not applicable, and then I'll put this in brackets, then this is false, otherwise it's true. In other words, if this match, this lookup, if it returns NA, then it's not valid, so this is false, otherwise it's true, right? So this is not valid, it's false. But if I enter one of these values in here, for example, I take main plateau 2 and I copy this value and I paste it in there as a value, then you will see it says true. It's now acceptable, right? Now here I cannot just copy this down. Even if I go and fix these cells, I cannot copy it down because my lookup here is not for the same lookup set over here. Instead, my lookup is going to be on the weather rating column, which is here. But what I will do is to just copy it down and then go and correct this by dragging this over there and shortening this list a little bit. Okay, so you just got to be really careful. And so because this ultra good is in this weather rating list, it is a valid value. And I'm going to do the same with the other two. Just remember, every time I drag down, it's invalid. So I'm going to press F2 and edit it by just dragging this list there and pressing then enter. And the same with this one. I'm going to just move it over there and press enter. Okay, so this clamped column is not valid for text data, so I'm just going to put a not applicable in there. And now I can use this same logic. This logic says if it is no data is true, then apply the default value. If it's not valid, then apply whatever the error label is that you want to have, and otherwise you can take the raw data value. So essentially that gives us just the if statement that selects which one of these values are valid. Okay, so I can again just take this formula over here. In this case the numeric formula is valid, except I will need to make one small change. I'm going to paste this as a formula. You see it's currently taking the value that's in this column as the final value, and what I wanted to take, if it's not a no data value and it's also not invalid, then instead of taking from column M, I wanted to be taken from the raw value over here, because it is obviously a good value. So I'm going right over here in column B and I'm taking that value, right? And this I can just copy down, and these then are my final values. What happens if I have a problem with my data? For example, I have one of the known or acceptable no data values like -999, right? See, currently it's just putting a 0, which it gets from this column, but I wanted to put, let's say for example, unknown, right? So this is going to be unknown then. And what if there's an error, right? So it's not one of the datas. What if it's not one of the values over here in my lookup sheet? These are the no data values. So let's say it's not one of these, but it's also not in this list over here. Like let's say something like that. In this case again, you can see it's not no data and it's also invalid. So in this case I may want to put an error, right? Or I can also make this unknown, which means I have to fill in a default or something like that downstream. And these min and max values, they are just needed for clamping of numeric values. So I can just put that in there and I can take this all the way down. And that is a good way for you then to check and validate text values before you go to a downstream process such as a deterioration model or whatever. And then once again, JunoViewer is going to extract these column names and these values out, and that is going to go to the downstream process. So we want to make sure that we take these updated and checked values right in here, and that is going to be our final values that is going to go to the downstream process. And that's basically it. So you can see for the text values, you have to make sure that you're handling all of the values and make sure that it is in the list of allowable values. Now, I just want to end off with one slightly more sophisticated change that you can make. Sometimes your values are going to come in from some external database or something like that, and they may have many data, many types of labels. But in your downstream process, like your deterioration model, you only want to handle 5 or 6 cases. You don't want to handle 37 different possible values, right? Now what you can do is you can use a funneling process to reduce the values, and I'll show you how to do that here. For example, you can see we've got quite a few zones here. And in these zones, you'll see, for example, I've tried to handle different spellings and different cases here as well. Now, let's say in our deterioration model, we only want to have 3 or 4 zones. And we're going to use a numerical value. So I can, for example, just do this and say zone number, right? And I will put a Z, just to keep it a text value, I'll put Z1. So let's say this is zone 1, and this is also zone 1, and let's say the delta is zone 1, but this is zone 2, and this is zone 2, and this is zone 3, and zone 3, and then let's say this is zone 4, and this is also zone 4. Now all I need to do is to make my lookup here for the final value slightly more sophisticated in this case. So instead of just taking B7, which is my value right over here, this value over here, so I'm just going to replace this invalid value with one of these ones. Let's say I take this one and I paste it in there, right? Now you can see over here my final value is main plateau. But I want to convert this to one of these, this set of reduced values. So all I'm going to do is just use a lookup value, right? So instead of using cell B7, I'm going to say VLOOKUP B7, which is my raw data value, in this list over here, right? Taking the second column, and I want it to be false. I want to make sure it's an exact lookup, right? And you can see that changes it to zone 3. Now, what will happen if this value over here is not in this list? Since I'm using an exact lookup, because this VLOOKUP has the false statement at the end, it means it will only accept the exact lookup. Since I'm using exact lookup, this is going to be an error if I do not have the proper value in there. For example, if I go to this raw data and there's just gobbledygook in there, then this value would normally throw an error. But because I've already off-ramped here to indicate that it's false, it's not a valid value, it's going to pick this value and it won't go to this lookup statement. All right, so you can see once again this is a fairly bulletproof way to handle your data, and that means this data that is going to go into your model downstream will all be relatively well checked and validated, and the chances of you getting errors and inconsistencies in your model is much smaller. I cannot stress how important that is. In my about 20 years of working with deterioration models, and specifically with users that have problems in running deterioration models, I have found that I would say at least half of the problems are due to faulty input data that are not properly checked and validated before they are fed into the modeling process. And the same applies to other types of processes, such as, for example, calculating totals on your ForwardWorks programs or for your network maintenance costs and things like that. So I think that is it for this video. I hope it's been useful to you, and thanks for watching.